stuff. Okay, so let's talk a little bit about what we were discussing, especially since we're going to be applying this a little bit now, about some of the things that you just discussed in the lecture. Okay, one of the most important things that we need to understand right now is that that data can be divided up into different types. The nature of the data presents it as a different type. For instance, nominal data. Okay, we knew that basically is a name. Categorical nominal data basically is a name. For instance, hair color is a name. Could be brunette, could be blonde, could be red, could be, and so on and so forth. We also have numerical data, and you discuss numerical data in terms of two kinds of numerical data, either continuous data or discrete data. Main thing, the difference is that a continuous data is data that's on a scale, a continuous scale, where discrete data very frequently is basically integer data. Okay, for instance, number of siblings that you have is numerical data, but it's discrete numerical data, right? Because you're not going to have 2.5 sisters. Right? That you might have a community might have an average of 2.5 siblings or something like that per family, but the actual data itself is going to be discrete. And ordinal data, which is basically a scale that doesn't really have the properties of continuous data. In other words, the differences between the values, although they have order, one is greater than the other, you can't really define a fixed value or an equal value between each one of the different categories. For instance, this pain scale, right? One person's 6 may be different from a different person's 6. And what one person may describe as the difference between a 6 and an 8 may not be the same as the difference between a 3 and a 5. Right? And there are many scales like this. Poor, fair, good, excellent, and so on and so forth might be a scale you might look at that way. Now, how about our A, B, C, D, and so on and so forth? Would that be an ordinal scale or a numerical scale here at Hunter? Well, it's going to be ordinal, right? Because we don't know when somebody got an A+, we don't know if they had a 97 or a 98.2, right? Even though it's kind of related to an actual numerical scale. But the number is a numerical scale. If you know that your average for a course was 87.2, you know what the difference is. You can quantify the difference between that and 97.2, right? Okay, so those are the main things. Now, as it happens, SPSS, the main software that we're going to be using, really only defines 3 kinds of variable. Nominal variable, a scalar variable, which is numerical or continuous, and an ordinal variable. Okay, and we're going to be mostly working with nominal and scalar variables in this course. Okay, difference between a population and a sample. Okay, we describe, there are a lot of numbers that we use to describe the nature of a population and the nature of a sample. And we use terms like mean, we use terms like standard deviation, and so on and so forth. As we go forward, we're going to be talking about how those are calculated. But we call those numbers, those descriptors that we use to distinguish between in order to distinguish them between a population and a sample, we term the numbers associated with a population, we call those parameters. And the numbers that we associated with a sample, we call statistics. Okay? And when we're talking about parameters or values for a population, we're usually using Greek letters. Mu, I didn't have them available, so I just wrote them out here. Mu, sigma, chi, and so on and so forth. When we're talking about the same values like mean, standard deviation, and so on and so forth, for a sample, we use regular letters like X for X, actually X bar, X with a bar over the top of it for mean, and SD for standard deviation, and maybe VAR for variance, and so on and so forth. So if we're talking about, if you see mu is equal to something, we're talking about a population, not a statistic. Now, we like to organize data because when if we have just a random scattered list of numbers, it's very hard to understand what those numbers may represent, where the middle of those numbers is, what the range of those numbers is. how those numbers cluster. Do they cluster around the center or around one end and so on and so forth? So we like to find ways to organize the data that helps us understand it. One of the first things that we do is we put together tables. In this case, we're talking about frequency tables. Frequency is the number of times that value occurs. For instance, in the one on the left here is the population in New York State for males and females. And we know that there's 602,000 males between 10 and 14. Okay, so by organizing this, instead of looking at a list of 19 million numbers, we have a table that we can reference that kind of gives us an idea what the distribution of this population is. Okay, and there's a similar table next to it for the number of I think it's number of marriages by month. And let's see, is that what it is? I don't remember what that was. July, okay, 13,000 in July, 14,000, 14,000 July, 13,000, so on and so forth. And it tails down beginning of the year, January, February. I think that's the number of weddings each month in New York, in the different boroughs in New York City. Okay, another way to summarize that information in frequency tables, maybe if they're nominal values, maybe to create a bar chart. Okay, a bar chart is simply a column chart where the height of the column represents the number of individuals, the number of results that satisfy that category. For instance, this is different hair colors, and this looks like it's about a sample size of about 30, and there were 2 people that had red hair and 12 people that have brown hair, and visualizing it this way gives us another look at this whole thing, a slightly improved look at what we had on the frequency table. Right? It's a little bit easier to understand it quickly at a glance. Okay, now, sometimes when we're dealing with information where these categories actually bump up against each other. For instance, if someone is 19.99 years old, right, the minute he turns 20, he's in the next category. So these categories are continuous. There's no gap between them. In a bar chart, with a nominal variable, it's like there's going to be gaps because there isn't kind of a continuum between red hair and brown hair and blonde hair and so on and so forth. You're either in one of those groups. Where with many other kinds of statistics, particularly numerical statistics, they can tend to overlap from one group into another because it's a continuous scale. Like for instance, in this one, heights of 30 people. Each one of these bars represents the number of people that are between 129 pounds and 139 pounds, 149, 159, so on and so forth. Okay, as the weights go higher, each person kind of falls up into the next category if they're in the next category. So there's no gap between these things, right? Because there's a continuum here. This is a numerical, a scale of variable, and instead of discrete numbers for each category, these bars represent a range of numbers between 139 and 149 and so on. Okay, this is called a histogram. We've got a bar chart and we have a histogram. Okay, so take a look at that. Males and females, number of males and females, bar chart or histogram? Bar chart, right? Okay, birth weight of 32 lambs. Well, histogram, right? Pretty obvious. Okay, whiskey bar chart. Candy bar chart. Okay, now you get an award if you tell me what the next one is. Whiskey bar, candy bar, sushi bar, right? Of course. Okay, so at any rate. Okay, another kind of chart that's very popular in statistics is called a box plot. How many of you guys ever use box plots? Okay, so how many of you guys have taken statistics within the last 5 years? Okay, other than this, wow, okay, well, we got our hands full this semester. All right, good. Okay, so many of you have seen box plots. And box plot, if you look over to the right there, I've isolated that first red box plot on the left-hand side. These are a number of box plots printed on the same table. And if you look at that one, that little whisker at the bottom, that line at the bottom, I can't point at that right now, represents, yeah. Where'd pop-up come up every once in a while. Yeah, now keep in mind I can't see this, so if something happens like that, just let me know. Okay, so if you look at that little box plot there, the whisker on the bottom represents the minimum value. The whisker at the top represents the maximum value. Okay, so in other words, from this group of subjects, the minimum value for diameter, this group of numbers, the minimum value for diameter was about 12. The maximum value for diameter was about 18. Okay, and the red box in the middle represents the interquartile range. The bottom of that red box represents the 25th percentile. In other words, 25% of the values are below that, 75% are above it. The top of that red box represents the 75th percentile. 75% of the values are below that, 25% are above that. What does the middle bar mean in the middle of that box? What's that? Means a good guess, but it isn't. No, it's the median. As it happens, it's the median in this case, right? So this is a really good, quick way to see the variability in a sample, right? As well as where the center is and what the range is. Really, just you can glance at it and get a lot of information from it. And if you plot them side by side, it really makes it easy to compare two groups or multiple groups even. Anybody know what that red dot at the top is? On top of that one. That's an outlier. That one is so far away from all the other values that most likely the software has selected that as something that may potentially be an outlier. For instance, who knows? Maybe somebody typed in the wrong number. Maybe it's a typo. Maybe it's not representative of this. You got a sample that was not representative of this population, and so on. Okay, another way of organizing data. In this case, we're organizing two pieces of numerical data, comparing a husband's husband's age to a wife's age, and we're looking at the amount of variability there. Notice it's much more variable in the 50s there, right? What is that? I'm not sure what that means, but anyway, so you can see that there's a relationship between a husband's age and a wife's age. I don't think this is legitimate because I know a lot of males that have somewhat younger wives here in that age range. So I think they made that data up. So graphical display of data can give you a lot of information. I'm going to play another quick video. Now I got to go through my little exercise here of turning my sound off. Okay, this kind of illustrates the strength of what you can do with graphics in terms of presenting information. Okay. Okay. Okay, so we're getting a little bit of hands-on practice right now. We're going to use Excel. We have a file that's on Blackboard. If you can get onto Blackboard, it's in a folder on the top of the lab folder for session one, and I think it's called something like descriptive statistics .xlsx. Okay, it's going to look something like what the values that are in there, that are input in there, are going to look something like this. And then we're going to move on to SPSS. We're going to take that same file, same data, and we're going to repeat the calculations that we do in Excel. And then we're going to play around a little bit with R. I'm not going to enter all that data in by hand, but we'll at least get a look at the differences in the interfaces. Yes. I'm sorry. Oh, we have it around on the Blackboard or something like that. All right. I'll tell you what. Let me get the date. Let me get the file up on display so you guys can see what you should be seeing, and then I'll kind of like wander around and see if I can't get everybody online. If you guys want to watch what I do here, I'll actually download the file right now. Okay, so I'm logging on to our course Blackboard. Mine's going to look a little bit different than yours, but not that much different. I'm going to click into the Lab tab. And if you scroll down past, on the top there, you have City Program, the links to City Program and instructions. You have SPSS, the link to on the hub, so you can, if you want to buy this software, I'm hoping you buy the software. And then you have the folder for session one. I'm going to click on that, and you'll see that right at the top there, practice files. There's a number of files in there that we're going to work with. This first one, descriptive statistics exercise 1_Excel. I want that one, so I'm going to right-click on that one and say download linked file as, and I'm going to drop it on my desktop so I have it there to work with. Oh, that looks strange. I'm not sure why that did that. But look at that. That's new. They up security here. You have to put in your, okay, or you can just click on it and it may open up for you. We don't want it to open up. We don't want it to open up as a window in your browser. We want it to open up in Excel. Or you can just download the link file, I guess. So what you should eventually get to is this file right here. It looks something like that. Yes, very successful. Okay, you got it. You know, the network's been laying. Oh, okay. I think what is, well, it's not going to be very complicated. You're not going to miss that much, but it's far along. Okay. If you're having trouble getting on, just like join your neighbors, put on your neighbor's shoulder or something. But it's not really, don't worry about it. You're not missing that much in this little exercise. How many of you have not used spreadsheets very much? Excel or spreadsheets, right? So we have a few people who may not have that much experience using spreadsheets. Some of the basics on using spreadsheets is that each one of these cells or boxes has an address that you can identify as a row, as a letter, and a number. Okay, the letter represents the column that it's in. The number represents the row that it's in. For instance, right now I'm in the cell B3. You can put one of three things into that cell. You can put a number. You can put a text or a label, January. Or you can put a calculation. Okay, now a calculation, where you enter a calculation into this is the simplest way is just when you're clicked into a box, the first thing you type in is an equal sign. And as soon as you type in an equal sign, if you look carefully up here at the top, over here by this this menu strip up here, or ribbon that I guess Microsoft calls it. If you look up there, when I put that equal sign in there, you'll see something change over there. And what's changed is that this bar is waiting for me to put in some values. Okay, there's an equal sign in it. It's waiting for me to fill in some more values. And what I can put in here now is a formula. And that formula can be something as simple as the number that's in A2 plus the number that's in A3. Okay, if you look, that's 99 and 104. And it'll add them together for us if I could enter. Okay, I could also type in there a function that's built into SPSS, into Excel. For instance, sum, the sum of a list of numbers. Well, this list of numbers goes from A2 through A19. I could type in there A2 and a colon A19, and it'll add up all of that entire list of numbers. Okay, and that's the sum of that list of numbers. Okay, there's a function called count. And let's say I want to know how many numbers there are. Now, it's pretty easy to see now because it's a short list, but maybe I have a much longer list or multiple columns. I can say A2 colon A19, and it'll tell me that there are 18 numbers in that list of numbers. I can do a number of things like that. Now, since I know how many numbers are in there, and I know what the sum of those numbers is, I can calculate an average or a mean for those numbers. Okay, and I can say that's equal to the number that's in F12. It's getting a little hard to find these, right? Because I'm all the way down here. Divided by the number that's in F13. A little hard to see that. So what I can do instead, I can type in that equal sign, and now instead of trying to figure out what that 1799, what the cell identification is for that, I can just click on that, and it'll put the F12 in there for me. And I can put a slash for divide and just click on the 18. And that's F13. It puts it in there for me. Hit enter, and it found the average for me. The average is a little under 100. Okay, so we can do all sorts of interesting things with Excel that involve calculations, okay, or repeated calculations especially. Now, if I click on this little f of x, now I'm using a Macintosh right now. When you use a PC, the layout may be a little bit different in Excel. As far as SPSS is concerned or R is concerned, it's identical. You won't notice any difference at all, I don't think. But in terms of Excel, that ribbon layout might be a little bit different depending on what version you have on the Mac or PC, or even just between the two. But you'll find that if you just look a little bit, if you don't see it in the same spot I'm seeing it in on the Mac, you'll find it on the PC. But most of the stuff's in roughly the same spot. So if I click on that f of x, it brings up a window that shows me all of the available functions. And in fact, we can actually, there's a section in here that's specifically statistical functions. How to find an average, how to find a standard deviation, and so on and so forth. So now I'm going to do something right now, which is kind of, not everybody agrees with me doing this. I don't know. I haven't discussed this recently with Levi, but I like to actually calculate a mean, a standard deviation, sum of squares, variance. Most of you guys know what those values are already. But I'm guessing it's been a long time since you actually calculated them from scratch rather than using a calculator, some device to do it for you. So I'd like to actually do that. So the first thing I'm going to do is I'm going to go onto my spreadsheet here, and I'm going to calculate the mean for this group. Now, you saw us calculate the mean one way, by adding those numbers up using sum, dividing by the number of values using count. We can also use a built-in value called average. I'm going to click in there, click equals, whoops, I messed that up a little bit. Click in there, click equals, and I'm going to type average. As it happens, the function for finding a mean in Excel is average. And rather than type in these individual, the range of numbers, I'm going to go up here. I'm going to click into the first number, drag down, without lifting my finger, and you can see it filled in the A2 through the A19 for me. Close the parentheses and hit enter, and there's the mean. Same number, of course, same number I got before. Okay, I could do count. I'm not going to need the count now since I already did the mean, so I'm not going to bother with that. Okay, so now the next thing I'm going to do is I'm going to calculate the difference between, I want to describe how variable these values are from the mean. How big a difference is there between the mean and these values? Are there big differences? The numbers are very variable around the mean, or are there small differences? Easiest way for me to do that is to just take the mean and subtract it from each value to see how big the difference is. Okay, so I'm going to want to take x minus the mean, x bar I'm calling it here. I didn't draw the, if you can imagine it's x with a bar on top. I'm just calling it x bar. Okay, so in order to do that, I want to make another column that has the mean in here. Right, so I'm going to click in here, and I'm going to say that's equal to 99, this value in here, 99.4. And that's what gets copied in there, right? So now many of you know that if you want to copy a formula or a number down in Excel, you can just click on it, drag down through the empty cells, and say fill down. Now on the Mac, this fill button is over here. On the PC, the fill button's on the right-hand side of the ribbon. Okay, but it's the same button. You see a little kind of down arrow, a little arrow. Okay, I'm going to say fill down. And it should copy that 99. Well, why it didn't copy that 99 down? Anybody know why it didn't copy that 99 down? What happens is it actually copies that number, but then for the next cell it moves down one, copies that number. Next one it moves down one, copies that. And since those are all blank below it, it just copied all those blank cells. That's called relative addressing, and that's important because if you have two numbers side by side, like the sales numbers for January and the sales numbers for February, sales numbers, the sales numbers for January, February, and so all the months in a column, and 1 year versus another, and you want to calculate the difference, and you want to put a formula in the first column, you want to copy that formula down, but you want the formula to adjust for each row, like row A times row B, A1 times B1, A2 times B2. So that's the way this is usually used. What we needed to do is just copy that same number down. So we use something called absolute addressing. So instead of putting B1, B21 into that first box, into the box B2, I'm going to put a $sign in front of the B, and I'm going to put a $sign in front of the 21. That means no matter what, just use that value. Don't change that value. So now when I copy this down, it copies the same number. It doesn't advance like that. That is an absolute address, not a relative address. Okay, you guys get that? Now you get a chance to practice with it later on, or I'll give you some more examples of it or something like that. How many of you just learned that in Excel? Is that new to any of you guys? Cool, right? It's a useful tool. So now I want to find a difference. Now I'm going to use relative addressing. I want to find a difference between each value and X bar. Okay, so I'm going to go in here and say X, 99A2 minus X bar. I'm going to hit enter, and okay, it's -1 basically. I'm going to copy all those values down. Okay, and you'll notice now it used relative addressing because I didn't tell it to use absolute addressing. So it found the first thing was A2 minus B2, and when I copied the formula down, the next one was A3 minus B3 and A4 minus B4, exactly what I wanted it to do. That's the difference between absolute addressing and relative addressing. Okay, so now to get an idea of how much the variability is in here, I'm going to add up all of the differences. I'm going to go down here into this blank box and say the sum of all of the differences. What am I going to get when I add up the sum of all of the differences? What do you predict? I got 0, basically. 2 to the minus 4, 2 to times 10 to the minus 14. I got 0. Why did I get 0? Well, that's the definition of the mean, isn't it? It's the average of all the, it's an average so that the differences are all averaged out, right? So I got a problem here. I want to use the sum of these numbers to describe how variable these numbers are, but I can't just use the sum. So I got two choices here to get rid of difference in sign, negative and positive numbers that cancel each other out. One is to just use the absolute value. Another way of getting rid of negative numbers is to square a number. So that's what I'm going to do. I'm going to take each one of these numbers and I'm going to square it. So I'm going to take this value times itself, right? And it comes out to a positive number now instead of a negative number. And then I'm going to fill down. I'm going to copy all of these numbers down. I'm going to do the same thing to every one of these. Notice I just automatically went to the drop menu instead of that little symbol that just, I'm old, that's a habit. Okay, so now what is this? What's a good way to describe these numbers? These numbers are the squares of the differences between the means and each individual value, right? Well, not yet. We're not quite there yet. These are the differences between the means, the squares of the differences between the means and each individual value. So I'm going to add them all up. And this time they won't become zero because they're all positive numbers. Okay, and it comes out to 892. That's called the sum of the squares of the differences between the means and the individual values, or just most people just call it sum of squares. Okay, that's an important value for us. That's an important value because the bigger that number is, the bigger the variability in your population, in your sample. The smaller that number is, the smaller. It's going to be a small, if there's the differences between the mean and each individual value are small, then that's going to be a small number. If the difference between the mean and the individual value is a big difference, the bigger that number is going to be, right? So that number is important to us. That's the sum of squares. Okay, so now the only problem with that number is it's out of proportion to everything that we've done so far. So I want to get it back into the realm of the numbers that we're dealing with for this population. And since I squared all of these numbers, I'm going to divide by the number, excuse me. Now I'm going to find kind of an average of this, right? A variability is kind of an average. And I'm going to take that by taking the sum of squares. I got a little ahead of myself there. I'm going to take the sum of the squares and I'm going to divide it by the sample size. Except there's a little twist on this. I'm going to use n minus 1, sample size minus 1. So instead of 18, I'm going to use 17. And we'll come back to that later on and discuss why we're doing that. It's related to this concept called degrees of freedom. So this is going to give me an average, kind of an average difference in the squares. Okay, and that's 52. That value is called the variance. Okay, so now I'm going to go a step further. I'm going to say to myself, well, that value is out of proportion to these numbers that we have and the real differences. So now, since I squared the differences, I'm going to take the square root of the variance now to bring that back down into a number that's more relatable to the actual differences. So I'm going to take this number, 52, and how am I going to take the square root of it? Maybe there's a function in Excel called square root. In fact, there is one, but it's abbreviated SQRT, parentheses. Now, I could look that up in the functions and find it that way, and just click on it and then fill in the value that I want to take the square root of. Or if I knew it, I could just type it in next to the equal sign. So I'm going to find the square root of 52, and that comes out to 7.24. And that number is called the standard deviation. And that's going to be really important to us. These numbers, its variance, the standard deviation, sum of squares, these are going to come up again. Sum of squares is going to come up when we work with chi-square. Standard deviation is going to come up when we work with t-tests and an analysis of variance and so on and so forth. These numbers are going to be really very basic to us. While we're here, I'm going to do a couple of other quick calculations. I'm going to find the minimum. Well, in fact, there is a function called min, M-I-N. And now all I have to do to put that to work is just scan these numbers until it's A2 to A, whatever it was, A19. And there's the minimum. And the maximum equals MAX, parentheses. And I'm going to do this. Hopefully some of this is recording, and you guys will be able to go back over this later on if you want to take a look at it. I'm thinking a lot of you guys are pretty comfortable with this anyway. Okay, and what's the range? The range is the difference between the maximum and the minimum. And that's going to be equal to this cell minus this cell, or 26. Difference between the minimum value and the maximum value is 26. Remember that box plot we were talking about before? In order to plot that box plot, what do I need to know? I need to know the minimum. I need to know the maximum. I need to know the median. which we'll get to in a second. And I need to know the 25th percentile and the 75th percentile. Okay, well, I'm about to calculate that. Let's calculate the 75th percentile. Equal percentile. And I'm going to put parentheses in here. And if you got it right, SPSS will give you a little bit of a hint. You may be able to see it there. It's very tiny letters there. It's asking for the array and comma K. If you go into the help for the functions, it'll describe those to you. But in fact, all that is, the array is just a list of numbers, comma, and that K is the percentile that you want, 0.75. And the 75th percentile is the value 104. 25% of the values are above 104, 75% of the values are below 104. So I'm going to do the same thing for the 25th percentile. Equals percentile. Okay, and I'm going to get the array again, comma. This time I'm going to put 0.25 for the 25th percentile. Okay, so what's my interquartile range? My interquartile range is the difference between the 25th percentile and the 75th percentile. In other words, it's the range within the middle 50% of the values in that sample are going to be. And that's going to be equal to 104 minus 94.5. And that's the interquartile range is 9.5, or between 94.5 and 104. So that's my interquartile range. What about the median? Wasn't that going to be that little bar in the middle of the box plot? Well, in fact, there is a function, median. Right? So for considering that this Excel stuff presumably had some other function, originally had some other function, it's got an awful lot of utility as far as statistics is concerned also. The median is 100. Okay? Everybody pretty comfortable with that? You got to feel that later on you could go through this, give it a try on your own. Okay, was this worth doing? Yes? No? Okay. So, right? So we now have kind of a basis to go forward with. We know where these numbers came from, right? I presume that you probably knew where the numbers came from anyway, but I think it helps to at least do this once in the semester, especially first session. Okay, next thing I'm going to do is I'm going to open up a file here that is an SPSS file. Now, unfortunately, I don't have a working version of SPSS on my laptop because ISIT can't seem to figure out where I am, so, or where I'm supposed to go to get it. So I am going to open it up on here. And it's going to be the same file that it's the same numbers that we were working with before. Okay, and if on your, here it is right here. Okay, on your version, it's probably going to say .sav because those are the PostScript for SPSS data file. I'm going to double click that and hopefully open it. And here it is. It opened up. Opened up quick. It must have been open already. It opened up very quickly. Here's the same values that we were looking at before. And this opens up and looks, SPSS looks very much like a spreadsheet program, right? But it's not. Because I can't go in here and put a function or a formula in that. I can only put data in that. In fact, the layout is very limited. The rows represent cases. Like, for instance, if we were talking about patients or subjects, that might be patient number one, and the columns might be variables. This might represent the patient's blood pressure. Next column might represent its weight. Next one might represent BMI. Next one might represent their hair color. Next one might represent the number of children that they have, and so on and so forth. The columns represent the variables, the data variables that you have. The rows represent each individual subject. Okay? So in this case, we have a variable by the name of V1. I didn't give it a variable. SPSS gave it a variable automatically because I imported it from Excel. An import file from Excel. You can actually look at this two ways. You can look at this in a variable view, where each row represents details about the variable, For instance, I could change the variable name right now to BP for blood pressure, right? And go back there, and you'll see the change. But we'll worry about that as we go on. So now here I've inputted these numbers, same numbers as I had before. Let's do the same statistical calculations. So now in order to do these calculations, I'm going to go up there. Now notice how the menus and the ribbon up here are specific to statistics. This is what's called vertical software. It's meant for a specific purpose, rather than software like Excel, which serves many purposes. I'm going to go into Analyze, Descriptive Statistics. I'm going to go over here to Descriptives. And I get a box up here. It says, oh, these are the list of your variables. There's only one in this case. And these are the variables that you want to work with. So I'm going to move that over into the box, which tells SPSS which variables I want to work with. And I'm going to look in here, and it's already going to calculate my mean and standard deviation. I'm going to ask it for my variance, my range, so on and so forth. Okay, I think that's enough. And then I'm going to say, okay, SPSS will run. And then if you look at the pack, and I'll do this again just so I can scroll up and show you the result a little easier. SPSS opens a new window called an output window. Right? We have two windows open. Data windows in the background. So if I go over to window, there's a data window, and there's a output window. Here's our output window. If you look at the output, it says, oh, there's 17 values. I must have lost one somehow. Minimum is that number. Maximum is that number. The mean is that. There's 100. The standard deviations. These are roughly the same numbers you got before, I think, right? So we're able to do our descriptive statistics very quickly, very efficiently, right? We didn't have to go through that whole exercise. With Excel, we didn't have to type in individual statistical functions and so on and so forth. This software is meant for this purpose. You're not going to use it to calculate your home mortgage, right? You're not going to use it to figure out how much your mileage is or anything like that. This is what it does, and it does it super well, super efficient. On the other hand, it's like easy to make mega mistakes, right? Since it's so easy to use, you can just drag that down here and do all sorts of, analyses that are not appropriate. So the real key here is the rest of the semester, we're going to learn how to use this correctly. Right? You know how to use it already, because you can say analyze and you pick something out, you know how to use it. You use a menu before, you know how to use it, so forth. How to use it correctly is a whole other story. It's a semester's worth of stories, right? Probably a career's worth of stories. Okay, so that's what SPSS looks like. Let's take a look at what R looks like. So I'm gonna stick with this since I'm here anyway. Set the contents. No, I don't have to do that. I'm gonna minimize this here. I've got to go to programs and R. Okay, I'm gonna open up R. Okay, here's what we get from R. Okay, see what I got there? I got a cursor. Not very inviting, right? Excel, you have this nice page with the spreadsheet and stuff like that. And now there's ways to get around that. There are other pieces of software you can use as kind of an overlay for this to make it easier to work with. But you get a console basically, right? And you can type stuff into this. For instance, you can type in, I can type in pi, right? And it comes back with 3.14. It's got values, constants actually built into it. I can say, unfortunately, I want if I can compress this window a little bit so it moves up. Yeah, I can move it up here. Okay. We need to go a little further. Okay, so I'm going to create a variable called A. Okay. I'm going to say that variable is A, and I'm going to say that inside that variable is equal to the number 6. Okay. Now I can say print, and I can print and spell it right. It's case sensitive, by the way. Print A, and it'll return that value that's in there. Yes. There's on here too. Yes. You have to go, and you won't see it in the immediate list of programs because nobody here uses it very much. But you'll see it like if you go into the drop menu, say all other programs, it'll be listed in there. Okay. So now I'm gonna assign some more values here. I'm gonna say variable B right? I'm going to say variable B. I'm going to put in a bunch of values in variable B. I'm going to use this little arrow, little caret, left caret, and a dash, kind of like we're moving these values into this value B. Okay, and I'm going to say, yeah, but we'll see here in parentheses, I'm going to put these numbers in here, 3, comma, 4, comma, 7, comma, 5, comma, 6, comma, 8, comma, and 9. Close parentheses, hit enter. And now when I look to see what's in that value B, that variable B, okay, B, okay, I get all of those values. Now I can manipulate those values, I can do all sorts of other stuff with those values. Let's talk about getting the statistics that we're interested in for those values. Maybe this is our list of numbers as we just did previously. Let's say summary, and I'm going to put summary of B, parentheses B. Hope I get this right. Spell it right. And there, it gave us the minimum value, the first quartile, mean value, third quartile. So I just use a command-driven program that put the numbers that I need in so and so forth. You can input files from outside. It has actually built into it a bunch of sample files. Data, with data and close parentheses, into parentheses, it comes up with a whole bunch of sample data files that you can work with if you want to. And you can do the same kind of thing. You import those data files in. You can use the commands that are built into it. I can give you a ton of links on YouTube, and there's a couple of seminars, there's a couple of courses on edX and Coursera on how to use R. Okay, and they're very good courses. You know, you'll really learn a lot about it. I don't use it that often, so I'm not very comfortable with it. Levi uses it every day, or most days. So he's much more comfortable with it. I'm much more comfortable with it. But it's your choice. You can use either one of it, especially you guys that are a pretty sophisticated group. If you're comfortable with it, I wouldn't shy away from this. I might have said the complete opposite. If this were a 750 class and was full of people that hadn't had taken much in the way of math courses or weren't comfortable with math.
There's a YouTube package called Swirl that actually did factory statistics.
I noticed that on their website.